Okay, so last part in section 6.3 for sine and cosine is looking at multiple transformations. So first thing we have to make sure we know is that when you graph multiple transformations, there's a certain order. And I tried to use the letters for each transformation that we learned during the week to tell you the order. Does anybody remember what the first transformation you would do is? Yeah. Sam?
Horizontal shift.
Yeah, your horizontal shift, which we call a phase shift. Okay, so that's always the highest order operation. You do that first. And then the next one, we're still inside the parentheses. So what would be the other transformation that's inside the parentheses? Megan?
The period change?
Yeah, the period change. That's your horizontal stretch or compression. After steps 1 and 2, you've taken care of the transformations that occur on the x-axis. Now we're going to do vertical stuff. What's the first vertical transformation we do? Stretch or shift? Yeah.
Shift.
Well, we had a 50-50, and it's not the shift. So it has to be
The stretch.
the stretch, which is our amplitude change. And then the last thing is the shift. So that's always the order you do the transformations in when you see them in a problem. I doubt you're going to see a problem with all 4. Okay, even the one on the test, I think it's 2. So just do them in that order. And if you're wondering, well, does the order really make a difference? Yeah, it does. Just think of like PEMDAS. It's a big difference, like if you wanted to multiply a number by 3 and add 2, well, you're going to get a different result if you do this. Let's take a number times 3 and add 2. If you do that first, or take a number, add 2 first, and then times 3. Okay. In one case you get 17, in the other case you get 21. So it's okay, it makes a difference. Okay. So the idea is we just do one transformation at a time. We're going to make a table for the first transformation, then we're going to use that table to do the second transformation. Right, so Shauna, what are the 2 transformations that are happening here?
Horizontal shift and vertical stretch.
Yep, we've got a horizontal shift and a vertical stretch. And Dylan, which one are we going to deal with first?
The phase shift.
The phase shift, yep, the horizontal shift. Okay, so for a phase shift, Gracie, which way does a phase shift move the graph?
It moves left.
In this case, it's going to move to the left, yes. So it moves it horizontally, which means the y values are not affected. So let's put down our y's from the original sign, and then we'll deal with fixing them when we do the second transformation. So 0, 1, 0, negative 1, 0. Sam, I'm going to take all my x's, and what am I going to do to find the new x values?
You're going to add pi over 2.
So we've got a plus pi over 2, but what do you have to do with a phase shift? You subtract, you do the opposite. So you'd have 0 minus pi over 2. The next one would be pi over 2, and you're going to subtract pi over 2. You would have pi, and you're going to subtract pi over 2. 3 pi over 2 minus pi over 2. And 2 pi minus pi over 2. So there's your phase shift. Okay, so we've taken care of that. And now it's important we get this table right, because we're going to use that table now to do the vertical stretch. So if we've got this table wrong, then the next table is automatically wrong. Questions on the phase shift table? Okay, let's look at the vertical stretch. Okay, Jayan, the 2, that's the only other number we have in the problem, so we know that's the vertical stretch. What values are not affected when you do a vertical stretch?
X's.
The x's. So we're going to copy those down, not from the original table, but from the one we just created. By original, I mean the one that we learned back on Monday. Okay, so we're not going back to that table. I'm going to use this table. So negative pi over 2, 0, pi over 2, pi, 3 pi over 2. Now, Megan, what am I going to do to all my y values?
Divide them. Divide the. Yes, the division.
Usually we don't think of this one as division. Not sure, Rebecca?
Multiply by 2.
Right, this is a vertical stretch, so usually we think about it as just multiplying by the number that's in front. So we're going to multiply everything by 2. 0, 2, 0, negative 2, 0. There's your table. In a multi-transformation problem, I'm not grading the intermediate table, I'm just grading the final table. 1 point for each x and each y value, just like always. Okay, now let's make a sketch. Okay, do I need to label my x-axis here? You think, Leo?
Yes.
Yeah, I'm not going to go by ones. I mean, you could, but that would be pretty awful to try to figure out these decimals. So we're going to use the spacing that's the x values. So we've got negative pi over 2, 0, pi over 2, pi, 3 pi over 2. I'm also going to label my y-axis because I'm not going to go by ones on that either. I'm going to go by 2's. 0, 2, negative 2. Okay, now make your sketch. So we get negative pi over 2, 0. And we're up at 2, 0, negative 2, back to 0. So the original graph has been shifted to the left. I think we can definitely see that, because that's x, that's y. How come I can't really see the vertical stretch here? That looks like it's the same height as every graph we've done all week. Yeah?
Change the units from 1 to 2.
Yeah, because I changed the scale. Right? So if you change the scale, you're not going to be able to see a stretch. Okay? But it's easier to change the scale, especially if you scaled something by, say, 30 units. You don't want to have to draw it 30 times as big. So change the scale. Any questions on that one? Okay, so phase shift combined with period change, vertical stretch. Okay, one thing to notice here is that the transformations were on 2 separate axes. We had one transformation that affected the x-axis, one that affected the y-axis. Now, I always want you to stick with that order. But technically, if you're only doing one transformation on each axis, the order doesn't matter because they're separate. When the order starts to become important is when you have 2 or more transformations on the same axis. Then you have to do them in the right order. But technically on this one, it wouldn't make a difference which one you did first. Okay, let's look at this one. Well, there's 3 transformations, so I know I'm definitely doing 2 on the same axis. So order is going to be important for that axis. Okay, so let's go through it and just identify what's happening first. Abby, can you tell me what the transformations are here? You don't have to tell me how much, just name the 3.
Phase shift. There's vertical stretch.
Yep, there is a vertical stretch.
Vertical shift.
And there's a vertical shift.
And phase shift.
No phase shift in this one.
Oh, so it's a period change.
That's a period change, because we're inside the parentheses, but this time we're multiplying. Okay. So the 2 is your period change, 3 vertical stretch, plus 1 vertical shift. Well, Juliette, which transformation out of those 3 do I do first? we do. Yep, we're going to do the period change first. Okay, so period change. Trevor, how does a period change affect the graph? What does that do?
It stretches it out, right?
Stretches or compresses which way?
Along the x-axis.
Along the x-axis. So the y's are going to stay the same for the first transformation. Tessa, what are my y values for cosine?
1, 0, -1, 0.
All right, so now we have to take all the x's and do some arithmetic involving 2. Okay, so what do you do to get all your x's in a period change? Yep.
Divide by 2.
Divide by 2, which is the same as
Multiplying by 1.
multiplying by 1/2, but you can't mix the two ideas together. Either the first thing he said or the second thing, but don't mix them. So I'm going to multiply everything by 1/2. So the first value is 0, it stays 0. The next one, what's half of pi over 2? Leo?
Pi over 4.
Pi over 4. The next one would be half of pi, which is pi over 2. The next one would be half of 3 pi over 2, which would be 3 pi over 4. And the last one, half of 2 pi gives me pi. And even though it doesn't look like a pattern, if there was a denominator of 4, you'd see a nice pattern. 0 pi over 4, 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4. Okay, so there's your period change. Now, the next two transformations are affecting which axis? X or Y? Yeah? Y. We can do both of them at the same time. You don't have to make a table for the first vertical transformation and then do another table for the second. As long as you do them in the right order, we'll do both at the same time. So x's stay the same. And can anybody tell me what we're going to do to all the y values? And when you say it in the order we need to do it. Yep.
Multiply by 3 and then add 1.
Multiply them by 3 and add 1. Okay, so let's just go through what all our y values will be. Tanya, can you give me the first one? If you triple it and add 1? 4. The next one, if you triple 0 and add 1, which is 1. Shauna, how about -1, triple it and add 1?
-2.
-2. Dylan, if you triple 0 and add 1? 1. And then we've done this one already, triple 1 and add 1? 4. Okay, so we just took care of that and that. Okay. Any questions on the table? Okay, now the graph. Okay, y-axis, I need to go as high as 4 and as low as -2. So I think I'm going to go by 2s, but I'm going to need one more grid line in there. We'll just pretend that's connected. All right, so we've got 0, 2, 4, -2. X's, I don't need any negative labels, but I just have to go from 0 to pi, and they're all equally spaced. That's 0, 45, 90, 135, 180. All right, so let's put those labels in. It's better if you put your labels at the bottom so we don't end up drawing over them. Okay, so we have 4, 1, -2. 4. 1 I have to estimate, but that's not that bad to estimate. It's just exactly halfway between. So 4, 1, -2, back to 1, and then back to 4. Any questions on that one? So I had 3 transformations in the same problem. The x one shouldn't be super tricky because it's by itself, but the y one, very important that, let me fix that. Close enough. The y one, very important that you do the transformation in the right order. Okay. Any questions on that now that I fixed it? All right, so we've done, let's see. We did vertical shift. Does anybody want to see another one? This would be a phase shift combined with a vertical shift. We haven't done those two together. Any questions on how you would do it? Yeah?
You could do them both at the same time, right?
You could, yeah. You could do both at the same time because it's on 2 separate axes. Phase shift is left and right, vertical shift is up and down. So yeah, I would probably do this all in one table at the same time. Any questions on how you do it? Okay. All right, so now some of these questions are going to get it using the calculator. It says find a complete graph. That's how you know you're using a calculator. Of 4 sine 3x. Okay, and let's even, when we say find a complete graph, let's say I want to see 2 periods on the screen. So I want to see 2 full cycles of that graph. I'm not saying a complete graph is always 2 cycles. A complete graph at a minimum is 1 cycle. But I would like to see 2 cycles. Okay, and they're asking us for 4 things: domain, range, period, amplitude. I think a lot of that we can find without without even using the calculator. Is there any one of those 4 things that someone thinks they can tell me without using a graph? Okay?
Isn't the domain all real numbers?
Yeah, the domain is all real numbers. Remember, these are always connected waves. So if they're connected and they go left and right forever, you can plug in anything you want and triple it and then take the sine of it. When we get into tangent and the other functions, that's not always true. The domain is not all real numbers. All reals. Anything else that we could tell quickly just by looking at the graph, the equation? Yep, Leo?
The range is negative 4 to 4.
Yeah, the range is going to be negative 4 to 4 because normally it would be negative 1 to 1, and you've quadrupled it, so it's negative 4 to 4. What you have to be careful of is if you do a stretch and then a shift, then the numbers wouldn't be symmetrical. Like if you took negative 4 to 4 and did a plus 1 and shifted it up 1, then it would be like negative 3 to 5. Okay, so keep that in mind.
Can you explain how you got
The range? So the range normally for sine, the highest and the lowest is negative 1 and 1.
Okay.
But if you stretch that 4 times as much,
Okay.
it's negative 4 to 4. Okay, anything else that we could get? Yeah?
Could you say that the amplitude is 4?
Yeah, amplitude is 4. And how about the period? This is important because if I want to see 2 cycles on the screen, you have to know how long 1 cycle is, and then you can double it to get 2. Okay, so how long is one period of this graph?
I don't know this graph.
Remember yesterday, there's a formula to calculate the period. Yep.
Would it be 2/3 pi?
Yeah, 2/3 pi, 2 pi over 3, same thing. So that's your period. So now, if I want to see 2 cycles on the screen, I have to set the width of I have to set the difference between my x min and x max to how much? Yeah?
4 pi over 3.
4 pi over 3. However you want to do that. I think the easiest way to do it is put the min at 0, put the max at 4 pi over 3. But that's not the only way to show a window that's a width of 4 pi over 3. Okay, so let's graph it. So we've got 4 sine 3x. Now I know the highest and lowest is 4 to negative 4. Negative 10 to 10 is, it's fine, it's more than you need, but that's okay. Let's set the y min at 0. Whoops, I did the wrong way. Let's set the y's from negative 5 to 5, and it's the x's. That controls how much of the period you see. So 0 to 4 pi over 3. So now when I type that in and hit graph, I should see exactly 2 cycles. There's half of 1, 3/4, there's 1 cycle, 1.5, and 2. So we get exactly 2 cycles. And that could change. Maybe they would say just do 1 cycle. Maybe they'd say show 3 cycles. Depends on the problem. Okay. So any questions on how we found those 4 things? Or a complete graph that showed 2 cycles? Important when you show a complete graph, make sure that you don't cut off the top and the bottom of the wave. You've got to see the whole thing. All right, let's look at this one. Okay, same directions, just a different equation. So find a complete graph of 3 sine x minus 1. Okay, what's the domain here? Jane, what's the domain?
Can be all real numbers.
Yeah, all real numbers. Every sine and cosine function, it's always all real numbers. There's no undefined values. Domain. I'm going to change this a little bit. I'm just going to put +2 on the end. Doesn't have any effect on the domain. You can't change the domain for sine and cosine. What would the range be now? Yeah, Leo?
-1 to 5.
Yes, -1 to 5. Because normally it would go from -1 to 1, but you've tripled it. So now it's -3 to 3, but then you've shifted that whole thing up 2. So if you take -3 and shift up 2, there's your -1, and then 5. So domain range, period. What's the period here? Yeah. It's 2 pi. There's no change in the period because there's a 1 in front of the x. So 2 pi. And lastly, amplitude would be 3. What if I put a negative in front? Would that change the amplitude? No. There'd be no change in the amplitude. Would that change the range? What do you think, Leo?
Would the range then be -5 to +1?
Well, I'm going to erase that, but if you put a negative in there, think about what that would do. Okay. Here's your original. Right? If you put a negative in there, a negative has no effect on the highest and the lowest that it goes. It just flips it. So if we kind of apply that to our problem, let's see if it still works. So here's the original. First thing you're doing is you are tripling the height, so then it would look like that. Well, if you 3, put a negative in front of the 3, that one would look instead like this. So putting a negative in front, now you're working with the blue one instead of the black one. And it's still negative 3 to 3, so then when you shift it up 1, it's still negative 1 to 5. So putting a negative in front has no effect on anything. Same, everything stays the same. The picture looks different if you were to graph it, but none of those things change. Okay, and then find a complete graph. All right, so let's type this in. So 3 sine x minus 1 plus 2. Okay, because I already found my range and my period, that really helps me to set my window. So let's set the x max from 0. And let's just go to 2 pi. We'll show 1 cycle. Negative 5 to 5 is okay for the window. It's going to be right on the edge of the screen, so I would probably do like negative 3 to 7. And then you won't be right on the edge. Okay, so we're looking at 1 cycle. I know that looks a little weird because you've shifted it by 1 radian. So you're getting kind of like the upward part, but you don't have all of the downward part on the left side. That comes in on the other side. Right? So if you wanted to fix that so you weren't looking at it kind of funny, you could shift your window a little bit. Let's see, if we shifted it to the left 1 unit from where we are now, minus 1 and minus 1. Now it should look, maybe I shifted it too much. Yeah, now I have the extra part on the other side, probably half a unit. I think if you shift it somewhere like, yeah, about half a unit, it would look more symmetrical. So negative 0.5 and plus a half would be 7. Like that. Okay, so hoping on the right side it gets to the bottom and you never see it going back up. That's kind of what I was going for. But it's up to you. As long as you have a window when you subtract your min and max and find the difference between them, it has to be 6.28 units for this graph. And that is. Yep. So any questions on finding a complete graph there, or domain, range, period, asymptotes? No asymptotes, sorry, that'll be tomorrow. Just domain, range, period, amplitude. All right. So, very first thing I showed you is that sine and cosine look almost the same. And this formula states that they are the same. They're just phase shifts of each other. So if you graph cosine, and then you graph sine, but take sine and shift it by pi over 2 radians, order of operations I think should be fine there. Okay, window doesn't matter, I'm just showing you these 2 graphs are the same. So there's cosine, and there's the sine shifted pi over 2 radians to the left. Now, that doesn't prove they're the same graph. The picture suggests it, but the only way to prove it would be with algebra. Okay, so basically what these 2 formulas allow you to do is take any equation that had cosine in it and rewrite it in terms of sine, or the other way around. You could take an equation that had sine, and you could change the trig function to cosine, as long as you change the argument, by shifting it pi over 2 radians. Okay, so that's called a horizontal shift identity. Any questions on that? All right, so the last thing we're going to look at is solving trig equations on a calculator. So let's say you graph a trig function and a line. And the line hits the trig function once on the screen that you can see on your calculator. What does that really mean? If you graph a trig function and a line, and the line hits the trig function once. What else does that mean? In terms of how often it would hit the line. Well, what are trig functions called? There's a category that they fall under. Does anyone remember what I called a trig function? Like sine, cosine, tangent, secant, they're all called a certain type of function. Do you remember?
I was going to say logarithmic, that's not right.
Logarithmic? No, they're not logarithmic, but it's a word kind of from the same idea, but just not that word. What's special about trig functions compared to like a parabola or a hyperbola? What makes trig functions different? About Jane? What makes trig functions different?
They keep going along the x-axis forever.
And as they keep going, can you describe the behavior as they keep going? It repeats, right? They're periodic. So trig functions are periodic, they repeat. So what does that mean? If you're looking at a window on your calculator and you see an intersection point on your screen, what does that mean in terms of if you were to look off the screen? Yeah, Leo?
At some point the line intersects the trig function again.
It's going to intersect it again. What if you kept zooming out? How many intersection points would you see?
As many as trig function crossed.
Yeah, which would be how many times? Assuming that it crossed at least once tells you that it really crosses how many times? Okay.
Infinite?
Infinite. There's infinite solutions. Okay. Because if this is your screen, and here's your picture, and here's a line, well, I can tell you I see two solutions, but if that behavior is going to continue to repeat, because the function is periodic, you're going to see two more solutions again and again and again in every cycle, every period. Okay? So this particular problem would have two solutions per period. Okay? So when we write the answers to solving a trig equation, we have to keep in mind, do they want us to write all the answers, which we can do, or do they just want us to write answers that are between certain numbers? Like, here's a low value, here's a high value, find the answers between the two. So for this one, they're asking us to find all the answers in a given interval. We need to understand that there are more answers, but this problem's not asking for them. Okay, so let's graph that and see if we can find the answers between 0 and 2 pi. Okay, any suggestions on how do I type this in to get going? What would be my first step? Dylan?
Put 0x and 2 pi on different y values and see where they cross. I'm not sure though.
Well, these are x values, right?
Okay.
So we're not going to put x values in on a y value screen, because those are important, but they don't have anything to do with y's. What up here has to do with the y values? Leo?
Sine of x and 0.4.
Right, sine of x and 0.4. And where would I put those in?
Y1, Y2.
Yes, let's put those in y1 and y2. So sine of x, 0.4. All right. Now I'm still not ready to graph yet. What do I have to do before I hit graph? Megan?
Set the window.
I have to set the window. Yep. And what should I set the window to?
The x max is 0.
Yep.
And the x max should be 2 pi.
X max should be 2 pi. Perfect. Now, just based on what we studied, I already know the highest and lowest that the sine goes is 1 and -1. So, the calculator comes back. That's okay, but let's just go -2 to 2. That's good enough. We'll hit graph. And now we have to find basically where the two graphs on the screen do what? Gracie? Where they intersect. Can someone remind me, how do we do that? How do we find an intersection? Rebecca?
Second calc.
Second calc, yep. Intersect. And now the guess is important because whichever one you're closer to, that'll give you the answer. So our first answer is 2.73. And second answer, do second calc, intersect again. And let's go over here. Okay, so for this particular problem, that's all they want. There's the two answers to the problem. Any questions on how we got the two answers? All right, but now I want to know what would happen if they wanted all the answers. Okay, how would we write every single answer? Okay, we can zoom out and we could find two more and do second calculate intersect again, but you can't do that infinitely many times, because there's an infinite amount of answers. Is there a pattern to how often the answers are going to occur in this graph? What do you think, Rebecca?
Yeah.
There's a pattern. Okay, so what we have to do is find the pattern. How often does this answer keep reoccurring? Right? So before I graph the next cycle and find that intersection, just to kind of give you a hint, does anybody have a guess at how often this answer is going to keep repeating? What's going to be the frequency of the repeating? How often? Yep.
Every 2 pi.
Every what?
2 pi.
Yes, it's going to repeat every 2 pi. How do you know that? Why? What's 2 pi?
The period.
Exactly, it's the period. So to figure out or to write all the solutions, you have to start with finding all the solutions in one period, which we've done. So we get 0.411 and 0.2730. But they're going to repeat every period. So you could add 2 pi to each of those and get the next answer. You could add another 2 pi, so you could add 4 pi, 6 pi, 8 pi, 10 pi. Keep adding 2 pi over and over, and you'll get all the answers. So what would be an expression that represents all multiples of 2 pi? How would you write that? Yeah?
You could do like 0.411 plus 2 pi like times n.
Exactly. Plus 2 pi times n, where n is an integer. So you could add 2 pi times 1, 2 pi times 2, 2 pi times 3, 2 pi times 50. But you can also subtract too. Integers can be negative. So you could take that answer and subtract 2 pi and get the answer before the first cycle. So that's how you write all solutions. So it's really not, it's not really a big step. Let me fix, I wrote this one wrong, sorry. It's not really a big step to go from finding specific solutions to finding all solutions. All you have to do in general is put plus the period times n. But remember, the period's not always 2 pi. You have a formula to find the period if it's not. Okay. So any questions on that? Okay, let's try this one. Except it's written backwards with the interval. Now, I did the same thing on this interval that I did on the last one. I put 0 is less than or equal to x, but then less than 2 pi. How come I didn't put the equal to on the 2 pi? Anybody know why I didn't do that? Yeah? Right, that's the end. Okay, if you think of it in degrees, a period starts at 0 and it ends at 359.9 repeating. It doesn't end at 360, because at 360, you're back at 0, now you're in the next cycle. Right? So if you include 0 and 360, that's a repeat. And that would be important because, let's say you had a graph that looked like this, and this was your window. And you had a line like that. You might say, oh, well, it crosses 3 times. Not really. This answer is a repeat of that answer. You're now looking at the next cycle. Okay? So that's why we only include the left edge, not the right edge. So whatever way you want to do it, but just include one edge of the screen. All right. So Julie, now how would I get this ready to type in? What would I have to do?
You have to do in 1
Yep.
2 cosine a half x.
All right, so we got 2 cosine 0.5. If you want to do a half, that's fine. Just decimal's easier for me. Okay.
And then 1 to 1.5.
1.5. Okay, and before I hit graph, what do I need to check?
You check the window.
Check the window, because in this problem, they are only asking for answers between 0 and 2 pi. So technically, you don't have to write all the solutions. I'm already set from 0 to 2 pi. All right, so we get a graph. And a horizontal line. And this time, there's only one solution. Sometimes that happens. Depends on how you stretch or compress the graph. So this time we've stretched the graph out enough. We've stretched the period, so we're not getting a full cycle on the screen. Okay, that's only half a cycle. All right, so second calc, intersect. Because there's only one intersection, you can just hit enter 3 times. The guess doesn't matter. And there's the answer. 1.445. Any questions on that? All right, this one's the same idea. It's just 2 trig functions. So when you graph it, you're going to have a wave And you might have another wave like that. You're just finding where the waves cross. Any questions on how you would do that one? The same idea. The thing about drawing two waves is that they could cross more than twice. A line and a wave never will, per cycle. You can never cross more than twice. But waves could. Maybe you have a wave like this, and then you have a wave that's compressed. So if that's one cycle, I know it looks messy, but if that's one cycle on the screen of this graph, the other graph crosses it a lot of times. Yeah.
So now would you find the intersection of the two waves?
Yeah.
Or the two waves on the axis?
No, because you're going to find where this picture crosses that picture, where the two pictures are equal. Yep. And one kind of interesting application for sine and cosine waves, can anybody think of a behavior that can be modeled mathematically that repeats every day? Something, how can I explain it? Something in this room that has a behavior of movement that repeats over and over every day. Same behavior. Yep. A clock. So if you think of a clock and you think of all the positions on that circle as coordinates, okay, you have an hour hand and a minute hand. So at noon, you could think of the coordinates at 0, 0. At 0, 1. Okay. Your minute hand and hour hand, if they were the same length, would both be exactly on the same point. But then, kind of an interesting question is, when does that happen again? When would the minute hand and the hour hand be exactly on the same coordinate again? Anyone have a guess? Besides midnight, that's really the same thing as noon. Anyone have a guess when it would happen again? Yep.
Like 3:15, 6:30, 9:45.
So 3:15. Well, at 3:15, right, this is your 3, and that's 4. At 3:15, the minute hand is right there, but the hour hand is already a quarter of the way past. So it's actually kind of an interesting question. It's a little harder than you think at first. Some people might say, oh, well, what about 1:05? No, because at 1:05, the minute hand is at the 5, but the hour hand isn't on the 1 anymore. It's a little bit past the 1. But there are 12 times, or actually would it be 11? I have to think for a second. There are a certain number of times per day where the minute hand and the hour hand are exactly on top of each other. And you can figure it out. Noon is the easiest one. But all the other ones are a little harder. But using sine and cosine, you could figure out when they're on top of each other, making a graph and finding intersection points. So that would be an interesting, that's kind of an application to that. There is a way to solve it without, you could figure that out without trig too. But sine and cosine works perfect because the behavior of the hands is periodic. It keeps following the same pattern over and over. So you could figure it out. You just have to take into account the period. Okay? How fast does the minute hand move versus the hour hand? Okay? They have different periods. One of them moves 60, how would you say that? One of them moves 60 times faster than the other one. I think I said that right. Yeah. So that's the period. That's all. Okay? Kind of an interesting problem I had to figure out once in school. All right, so the last one we'll look at, a little different. What's different about this problem? Yeah?
It's an inequality.
Yeah, it's an inequality. So when you have an inequality, your answer isn't equals, it's an interval. It's between 0.5 and 0.7 or something like that. Okay, so let's graph this and see if we can figure it out. So we've got 2 cosine x and negative 1.3. So as far as typing it in, you don't do anything different. Type it in the same way. Windows should already be set from the last couple problems. Okay, so there's our cosine graph, and we're looking for where the cosine graph is greater than negative 1.3. So first thing I want to ask is, does that ever happen? Jane?
Yeah.
Yeah, it does happen. Because if it didn't happen, then we'd say no solution. But it does happen. And can you describe to me, Jane, where the cosine graph is above negative 1.3? You don't have to give me numeric values. Just kind of describe where you're, because you told me it is above. Can you just, like, just describe kind of where it's above?
Well, all the points on the cosine above the red line.
Yeah, everything above the red line. So we're above the red line from here up until right there. So let's write down generically the coordinates for that point. What's the x value for that point? Pretend you didn't have a calculator. Would you know the x value? What do you think, Trevor? No, we don't know the x value. But what's the y value? Yeah? Yeah, of course, it's negative 1.3 because that's right on that line. So let's just call that x1, negative 1.3. And for now, without doing an intersect, because I'm sure you guys could figure that out, what would be the coordinates of that other point? Yeah? Yeah. Again, you'd have to find what x1 and x2 are, but we've already done it. So now, when I describe where I'm above the red line, is it going to be everything between those dots? Or everything that's not between the dots? Rebecca? Not between the dots. So we're going to go from here to here. We're going to skip the middle, and then from here to there. All right? So the lowest x value that I have on that graph, well, what is it? What's the lowest x value? In my window. Sam?
Oh,
Lowest x value in the window.
yeah, it'd be 0.
0. Yep. So we got 0, and I can include 0 because of that. I do include 0. And I'm going to go from 0 up to what x value? Abby? We're going to go from 0 up to
Negative 1. X1.
x1. Yeah, we go up to x1. Now, the question is, do we include x1 or not include it? Caleb?
No, because there's no equal. It's just less than.
Greater than. Yeah, it's just a greater than. Right? So, just in this case, you do not include x1. If that had an equal to under it, then you could. Okay, but we don't want to be equal, we want to be above. Or, can anyone describe the next section where this graph is above the red line? Yep.
It'd be x2 with a parenthesis,
Yep.
and then 2 pi with a bracket.
All right. Can we include 2 pi?
No.
No. So for that case, we'd have to put a parenthesis. Okay? So to determine the brackets and parentheses, you have to look at the window And you also have to look at the symbol in the problem. Okay, any questions on that? The only thing you have to do now is find the two intersection points. Any questions? All right. So the last thing, I don't think I'm going to start 6-4 really. I just want to show you the kind of graphs we're gonna see tomorrow. So up until now, everything's been nice and connected. I'm going to show you what tangent looks like. So it's still a periodic graph because it repeats. It has that repeating behavior, but it's not connected. What do you think this graph has that sine and cosine didn't have? And I said it earlier when we were talking about domain, range, period. Yeah.
Asymptotes.
It has asymptotes. And they occur very regularly. They occur every cycle. And that's the same for tangent and cotangent. Well, if we want to graph secant or cosecant, we can also graph that. But we got to be careful because when you have a fraction, the bottom can be 0. If you graph cosine, does cosine ever cross the x-axis? Caleb?
Yes.
Yes, it does. So if cosine crosses the x-axis, that means it has a value of 0 at different points. Well, that's a problem. Because if you're graphing secant, cosine is in the bottom of a fraction, and we just said now the bottom could be 0. So what do you think this graph is also going to have? Like tangent. Yep. It's going to have asymptotes. And it's going to have an asymptote at every single spot that cosine would cross the x-axis. So what we get is these kind of U-shapes and N-shapes. That's secant. Cosecant looks very similar. Because remember, sine and cosine are just phase shifts of each other. So if you put cosine in here, you can see everywhere that cosine crosses the x-axis, that's where you get a vertical asymptote. Because that's where you'd be dividing by 0. All right. So tomorrow we'll take a look at the last 4 graphs. We don't do much sketching by hand. In fact, I don't think we do hardly any. But things you're going to have to know how to do is find like domain, range, period, and asymptotes of these functions. And solving equations, but that's the same as what we did today, finding an intersect. Okay, so we'll finish that up tomorrow. So homework tonight, I don't have a worksheet. Okay, so these are just questions in the book. So page 346, 2 through 4, 7 through 10, 15, 17. 21 to 23, 29 to 32, and 36, 39, 43. Okay, and you've got a little under 20 minutes left. So some extra books if you want to get started. And if there's any questions, I'll try to help you out. Don't forget, this is the last homework assignment for the week because on Thursday, we're going to do the take-home test. So Thursday night's homework will just be take-home test, and that will be due on Friday. Is there any concern about the test being due on Friday? It'll be due Friday right at the beginning of class. Okay, so Friday the periods are 2, 4, 6, 8. So I see you guys right away. So the test is due by 7:45 on Friday. If you are not here and you don't get it in by 7:45, then it would be a 0. Okay, so if you're not going to be here, make sure you scan it, email it to me, take a picture or something. All right, just make sure you get it to me by 7:45.